You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, thank you, very good.
Bernie is our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly, thanks for asking. So this will be Friday, July 8th. We'll have basically a waxing gibbous moon. The first quarter moon was back on July 6th, and the full moon will be on July 13th, and that's called the hay or the thunder moon. So this is just after the fireworks. I don't know if you heard our show about last week, but we were talking about fireworks, and I got to see quite a few of them and got some good pictures of them too. So pretty much all the action is still in the morning sky. We did lose Mercury by now, but you still have the other 4 planets all lined up in order: Venus, Mars, Jupiter, and Saturn. And even Uranus and Neptune are there if you happen to be lucky enough to get a hold of a little telescope or something. But you can see 4 of them by yourself still up there in the morning sky. The days are getting shorter because we're like a couple weeks into summer, so they're down to 15 hours and 17 minutes. It's still pretty long, of course. So basically now the sun rises at 5:07 and sets at 8:24. And since we have a waxing gibbous moon, that comes up around 3 p.m. and sets about 1 in the morning. So it'll be in the way until a while, and then if you're up late, then you can see other neat things in the sky without the moon. So we got a pretty good week coming up, and keep looking for the planets if you didn't catch them last month.
Awesome. Thanks, Bernie.
Yeah, you're welcome.
And if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald. So welcome to another episode of Scientifically Speaking. We have brought forth climate change discussion to our listeners several times over the years, and the little that we do understand, we do at least know that it is a very ubiquitous topic that does happen to find its way into many of our shows. And in fact, one of the pollutants and contributors to climate change, particulates, we actually touched upon in last week's episode. As Bernie had mentioned, we talked about fireworks and the matter that is expelled and released into our environment from those. And several episodes ago, we unfortunately, talked about Dr. Catherine Hayhoe's book, Saving Us, that gave us a very hopeful framework for which to discuss climate change. And many, many moons ago, we had, who has also returned, Keith Launchbury, where we talked about circular economies as kind of a realistic means to cap our outputs. And today, we are lucky to be joined by Bernie. Could you please introduce our guest?
Yes, certainly. We have Dr. Yue Zhang. I met him actually a couple times at our observatory. We did a whole special show for him and a friend just about a few weeks ago. And I remembered to ask him if he wanted to join us, and he remembered meeting me there a few years before that. And then before that, he was an undergrad, and now he has a PhD. So I'll let you introduce yourself a little bit and what your qualifications are, Dr. Zhang. Go ahead.
Yeah, so hi everyone from Portland and also Maine. It's actually really great to be here to talk about a little bit of climate change and my research and how that's relevant to everyone. So my name is Dr. Yue Zhang, and I'm currently a professor at Texas A&M University. And my research is to study aerosols in the air, which are little particulate matter. And then these kind of particles actually are very prominent and very popular. They can have like more than 1,000 of them in just a very small area, like a size of your thumb. And then they're very important to climate and also air pollution. And that's essentially part of my research is to understand how they can cause human health effects and how they can affect the climate. So I guess in the next half an hour or so, we're going to be talking about that. And we're very, very excited. And thank you for having me for Sarah and Bernie.
Oh, thank you. Thank you, Dr. Zhang. So first off, how did you become involved in this work? It sounded like you'd been looking into this or interested in it since you were an undergrad, but did it start early on?
Yeah, I would say that when I stepped into this research field, it was partially because of my interest. Partially was a little bit of luck or accident as well. So when I was in high school, like just like every scientist, I guess, I actually really like chemistry. I also like biology. So I was thinking, how do I combine these two subjects into one? And that's when essentially I went to college. I decided to study environmental sciences because that's essentially use lots of chemistry and biology. So after that, environmental science is very broad. So it includes the water, the soil, and also the atmosphere. So when I was a sophomore, so I started to work in undergraduate research, and I happened to be working with a professor who actually is trying to study the Beijing Olympics and also the air pollution at that time.
Mm,
That's a very interesting topic for me. So I started joining his lab and working on this. I actually participated and helped in the air pollution control during the Beijing Olympics. And then since then, I started to like it more and more. So after my undergraduate, I actually went to Harvard for my PhD. And there I also trying to understand how all these little particulate matter in the air will impact on the air pollution and the climate.
interesting. So you helped to control air pollution during the Olympics? Like you physically helped to do that?
Yeah, so I we had a huge campaign, and then which a campaign means we deploy all the instrument and personnel, try to measure all the air around Beijing, even 1 to 2 years before Olympics at that time. And then we essentially, I remember I have to go to the top of a roof of a very tall building and then start to sample air every day at certain time before and during the Olympics. So based on analyzing the composition of the air, then people can understand where the pollutant might be coming from. And then from then on, then the policymakers will be able to tell different kinds of pollution emitters or factories or essentially public transportation to reduce the car or reduce pollution to help control the air pollution. And that was actually quite successful because I think during the Olympics, during that 20 days or so time, the air quality actually improved a lot.
Wow. During the
Yeah.
Olympics,
Too
Yeah.
when
bad
you
it,
have like
it did.
millions of people
Yeah.
there.
And
Yeah.
I remember that I was like, oh, wow, it actually looked really nice. The sky is really crystal clear. And then, we had shower like every a few days. It's just really pleasant compared with maybe even before the Olympics. You could see that how we can just work as a team, try to make our environment nicer and more habitable for everyone.
Yeah. Wow, that's fascinating.
Yeah.
I didn't know that. So funny that you mentioned that because I feel like this was probably a few years ago, but I think this was news that came out of China where they had basically constructed and erected these giant um what are those called? You know, when you put them in your room and they kind of filter air. They're like air purifiers, but they have like giant building size ones. Were you like involved in any of that?
So I'm not personally involved, but I do know that one professor in China that I'm aware of. So he is actually involved in these giant towers, and I think that this tower kind of sucking all the air from above, and then filter the air, and then release the air from the bottom. So when it's near the ground level where people live, then essentially people can breathe more like cleaner air, I guess in that sense. But on the other hand, these towers probably can only have effects in a small area. So if you want to control large scale pollution over the whole city or even a whole area, then you probably need other control measures to work together.
Gotcha. What could you go into a little more detail about what measures that were done or that were put in place to help curb pollution during the Olympics?
Yeah, so during the Olympics, there are a few ways. So in Beijing at that time, so a lot of the pollution comes from either uh, factories, industrial activities, and also car exhaust because there are so many cars in such a large city. So what people did at that time is we try to reduce the amount of the air pollution from the factories. So at that time, my undergraduate advisor, so he was in charge of the whole pollution control. So he essentially makes suggestions on how to reduce different kinds of factories, and then maybe even kind of sadly, but some of those factories essentially had to stop operating for the whole
Mm.
months of the Olympics. And then the other part they were trying to do is that in Beijing at that time, they essentially curbed the traffic by half by only allowing even an odd number of the license plate to be on road each day. So in that sense, half of the cars can be on the road. So that's also reducing the air pollution from vehicles by half.
Wow.
Mm.
So that's more of a like stopping activity, I guess.
Right,
Yeah.
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 And at that time, so air pollution is always related to the meteorological events as
Mm-hmm.
well. So at that time, it happened to be also the meteorological conditions also favor the pollution dissipation.
Mm.
So with both the source emission control and also the meteorological favorable conditions, they really help make the air much cleaner. Yeah.
Wow. That kind of reminds me of early on during when the pandemic started. Remember how we couldn't go anywhere and people were like, "Wow, the skies are so clean because there were no cars on the road." It kind of sounds like that.
Yeah, I feel like Sarah, maybe you should join us to be a professor in environmental sciences because that's exactly what some of my colleagues did. For instance, I know a colleague at Boston University, also a colleague at MIT. So they actually deploy their sensors during the pandemic to compare how much pollution has reduced before and during the pandemic. And you could see that there was a really visible statistically significant change on how much pollution actually has been reduced and the air has improved.
Yeah, yeah. No, that was a really interesting time. Although it was sad to see, it feels like it bounced back like double afterwards when, when cars were back on the road. So it was
Yeah,
just like
well,
a flip.
yeah, I mean, each of us, as humans, we keep generating exhaust to environment, right? So unfortunately, when we start become more active, then we also emit more. But I still remain hopeful that I think as we understand the environmental situation is much better, and also everyone's becoming more aware. So the pollution issue is going to gradually become less and less.
Yeah, yeah. Great. Well, thanks for sharing that. That was really fascinating. Had no idea.
Thank you for reminding me of that.
Yeah.
So your research is you mentioned aerosols was the big thing, and I think we've kind of talked about that. But when we talk about the word aerosol, what exactly are we referring to? Like, is it just car exhaust? Is it just kind of pollutants from factories, or are we also talking about like paint drying or spray paint? I don't know. Like, what does aerosols encompass?
Oh yeah, that's also such a great question. This is actually what I talk about in my class. So it's normally in the first lecture, I would teach the students. I said these aerosols are not the aerosol spray you put on your hair, but these are actual aerosols in the air. That's important for everyone. So it's the scientific definition is like anything that's suspended in the air together with the air around it. So if you have any solid or liquid particles, then these kind of particles together with the air just right next to it is characterized as aerosols. And then, so in reality, the aerosols can come from many different sources. We normally divide into two parts. One is coming from natural sources, which we call it biogenic, which comes from trees or animals. The other part is from human actually produced sources, which we call anthropogenic. And then apparently before us even exist or before the industrial revolution, so there are already lots of aerosols in the air. They naturally exist there. And then these are little solids, particles or liquid particles in the air. So they can help to make the clouds. But because of the industrial revolution and us actually start to make more waste, so we actually start to contribute a lot of the aerosols in the air. So it enhances the total concentration. And then that may cause a lot of issues such as impact our health by inhaling into the lung, but also they can affect the properties of clouds, which will impact the climate change.
And so, when it comes to kind of the impacts on the environment and the impacts on, how it contributes to climate change, what is so bad about having, liquid and solid particles suspended in the air?
Yeah, so what happens here is that in the natural environment, let's say we actually don't have any aerosols at all, no matter whether they come from biogenic or anthropogenic sources. Then what's really going to happen in the real world is that clouds likely won't be able to form. The
Hmm.
reason is because we know clouds actually are made of either water droplets or ice crystals. So if the clouds are much higher, then they're made of ice. If they're lower, they're made of water, or they can be both. So to actually make them into a water droplet or ice crystals, so you have to reach saturation. Essentially, the water vapor is going to be more than what the air can hold. So essentially, it's going to condense to become water. So the humidity has to reach 100%. And then, but that's not just the only way to make clouds. In the super clean environment that's free of aerosols, just has air, then even when you have the humidity reach 100%, even 120%, 130%, you still cannot make clouds. This is because you need an energy barrier for the gas water vapor to condense to form this liquid or ice. But then the way the aerosol does is that it provides a surface to make water vapor much, much easier to become droplets or ice. So that actually can enhance the formation. And we know that in the nature environment, normally the humidity is only like 100.1 or 100.2. Then because aerosols are there, then they can essentially already make droplets of ice, or sometimes even higher. But yeah, so in that sense, without any clouds, then the sun can directly actually evenly get onto the Earth's surface. There's no reflection of the sunlight. So the Earth actually may receive much more energy than what it would have been now, and that's going to warm up the Earth's surface even more. So, but with all the natural aerosols, so now we have clouds, and then that's why the Earth is going to be a little bit cooler, which is to reach our current temperature. So what's going to happen in the future is that as our humans also emit more aerosols into the air, these kind of aerosols emitted by our humans actually are different from the naturally produced ones. So they can either enhance or suppress the cloud formation. And that's going to create lots of disturbance and uncertainties in understanding how the climate may change. So they're very, very crucial to the climate change. And one thing I would like to add here is that according to an IPCC report, which is an inter-panel on climate change, so they think that based on all the scientific understanding people have found so far, so the way aerosols interact to form clouds is actually the largest uncertainty in predicting future climate. Even more than carbon dioxide. Carbon dioxide, even though it's a large contributor, but its uncertainty is not very big because we already understand it very well. But for aerosol and clouds, it's still hugely, hugely uncertain. And that's why we're very excited to understand this topic.
Is it just uncertain because it's hard to experiment on it, or
Yeah,
is
so
it just because there's such a mix of aerosols?
yeah, so it's actually because of both. One way is because mimicking how naturally the aerosols can form liquid or ice clouds or facilitate the formation of liquids and ice clouds is a little bit tricky, because you want to exactly mimic what the natural aerosols in the air look like coming from either humans or the trees. And then that's hard to do because the aerosols can exist in many different kinds of forms. They can have different shapes, and all of these and different composition. All of this will impact on how they can impact cloud formation. So that's one thing. The other thing is also our experimental techniques need to actually improve more to be able to understand how to simulate this process more by reaching 100% humidity and characterize it. So yeah, so there are multiple factors. And also, even if we know it very well, then putting into the models is still very hard because at different locations, you can see the aerosol concentration or composition can change drastically, right? So the model has to capture all these little details, and it's normally very hard to do as well.
Yeah. So when we talk about like experimental techniques, do you do experiments in your research or
Yeah, so I am 3/4 of an experimentalist, which I sort of this research in my lab. So I do have a lab with my graduate students and undergraduate students working there. I also do a little bit of field measurement, which we
okay.
deploy our instrument into the outside air, and then we essentially measure what the air is really like. So in the lab, we have a controlled environment. In the outside air, it's much less controlled, but we can compare these two and understand what are the differences, how we can translate our lab results more to the ambient. And I also do a little bit of simple modeling as well, but I mostly work with modelers trying to put our field data and experimental data into their more large-scale, complex, global, regional models.
When you experiment in the lab, do you have like a cloud generator?
So that's actually an excellent question. So it depends on different labs. So we have different techniques to do that. So in Europe, So they build actually a really large cloud generator. It's called AIDA chamber. So that chamber essentially uses, so in Europe, they have CERN, which is this electro um, magnetic accelerator to let the particles collide, right? So it's a particle collider to
Hmm.
explore fundamental physics. So to actually make this really large scale particle collider, they need lots of cooling. So the excess cooling is actually used to run the AIDA chamber, which inside the chamber, you can cool the temperature to minus 30 or 40 degrees Celsius to mimic what's happening in the upper part of the air. Then as
Oh, wow.
goes down, yeah, it's a really large chamber. And then you gradually you inject aerosols, and then as the water vapors start to reach supersaturation, which is more than 100% humidity, then gradually the ice or liquid water is going to condense onto the particles, form a little ice or particle clouds. And then they essentially use all kind of instrument trying to measure this kind of liquid or ice clouds. So that's one of the technique. So in my lab, we have an instrument which it can actually, when you generate aerosols, then it passes through a chamber. In that chamber, it increases the humidity to more than 100%. So after that, then the water will vapor condense to form liquid droplets with aerosols. So we're essentially making little clouds in a super small chamber and try to calculate how easy it is for different parts of aerosols to make clouds.
That's so cool. How can you like see these clouds, or do you just see it in numbers, I guess?
So for the instrument itself, we have to exactly quantify them. So the instrument will have a laser beam trying to quantify how many of these little water droplets are there. But you can
Mm.
actually easily make clouds in the lab. So I also made in the lab before too. And I have a colleague who's at MIT, and then he also made these clouds when they are undergrads or kids coming to visit the lab. So what you can do is that there's a large jar, and then there's water in it. And then you essentially reduce the pressure inside this jar, so the water will essentially become 100% humidity. Now, in that sense, you don't see anything at all. You don't see any cloud because that jar is super clean. So
Mhm.
as we know, in a clean aerosol-free environment, so even though when the humidity reaches more than 100%, there are no clouds. And then what you can do is that you can light a little match. And then if you blow the match off, you can see there's little smoke coming out, right?
Mhm.
So as long as you put this little smoke into that jar, then you're going to see that immediately you see lots of water droplets start to form, and then it becomes the whole jar becomes non-transparent because clouds actually formed in that jar. So
Wow.
you can do this even at your home, and then to mimic how clouds form in the actual environment in the atmosphere.
How would we reduce the pressure? Do we just do something like canning? Like
Yeah, so
you heat it up?
we normally connect the jar with one inlet to a pump, so it's drawing the air out to reduce pressure. But if you have, I think that if you use a mouse to, reduce the pressure, maybe that will work too. I haven't tried it, but maybe I'll try it. And
That's super cool. Like a little home experiment.
yeah, actually,
Neat.
I mean, this way is a really easy way to share with people how aerosols can make clouds and change clouds, and how we humans emit aerosols may change clouds.
Mm-hmm. Mm. Wow. So aerosols impact climate change because they can enhance or suppress cloud formation, which impacts our global like heating, basically, heating or
Yeah.
cooling.
I mean, the other way, so this is what we call indirect effects of aerosol because they form clouds, and clouds
Mm.
affect the solar power reaches on Earth. Another way is called direct effects. So the aerosol itself can also scatter or absorb lights, right? Because as you
Mm.
know, in a very polluted day, then the sky looks kind of grayish. That's because all these aerosols actually already scattered the lights from the sun. So that also kind of reduces the amount of energy reaches the Earth's surface. But this is actually not as significant in general compared with the form of clouds, because clouds is much whiter and much more effective at um, reflecting sunlight.
Hmm. Is if we're looking at like kind of those gray, like the gray sky because of aerosols have kind of polluted our skies, does that you said like clouds are a little more effective, but if the whole world like didn't have clouds anymore and just had like aerosols, do you feel like we would see more heating then?
Theoretically, yes. So what happens is when there are no, so one thing clouds does, so most of the clouds
Hmm.
are cooling the atmosphere. Some clouds can warm the atmosphere, but that's a different story. So for most of the clouds, when the sun hits into the Earth's atmosphere, it hits onto the top of the clouds. And as we know, clouds are white. So a lot of the solar energy hits on the top of clouds and reflects back to the space. And that's why you reduce the amount of energy the Earth can take from the sun. And then when the Earth is cloud free, then what's happening is that all this solar energy reaches onto the Earth's surface, and a lot of them can get absorbed by the surface. So naturally, you would think that the temperature on the Earth's surface is going to be a little bit higher or much higher because we actually the Earth absorbs more solar energy. The clouds actually account for a really large percentage of the Earth's surface, so they really effectively remove a lot of the excess energy the Earth actually would have take from the sun.
Wow, it's like sunblock.
Yeah,
I
absolutely. Thank you. Yeah, I mean, a lot of times it's hard to associate. Oh, wow, the aerosols actually have such important effects in cloud formation. And
hmm.
then, so now, I even look at clouds differently. I'll say, oh, maybe some of the aerosols I examined in my lab actually made that clouds.
if if it's so good to have the clouds, if that would work on a larger scale, if you could just make more clouds and then have less heat come to the earth and reduce global warming that way. I don't know what scale you can do this on.
Yeah, so regarding how aerosols and clouds interact, which we call aerosol cloud interactions, there are still lots of uncertainties in that aspect. So most of the clouds, especially lower level clouds that we see typically, they actually reduce the amount of the solar energy that reaches the Earth. So we are thinking that maybe that's going to help cool down the Earth. But at the meantime, these higher clouds, like cirrus clouds, they actually in, absorb more energy. So it actually warms up the Earth. So we're still trying to understand how the aerosols may try to contribute in these two different ways because they're competing with each other. Another thing, the clouds and aerosol interaction, which I didn't mention, is that it may also affect precipitation as well. Because as you can think that when there are not many aerosols, then each of the cloud droplet will be much larger because there's this amount of water can only condense onto fewer aerosol particles. But when humans produce more of the aerosols, then sometimes what it can do is it can make lots of smaller cloud droplets or crystals. And maybe that will make the droplets smaller so they can suspend in the air longer. So the clouds may just suspend there instead of form as a precipitation, as rain or snow. So that may also change the precipitation pattern. But this is also not like always determined. Other situations, the clouds, the aerosols may facilitate the precipitation in those like really clean environment that doesn't have any aerosols, right? If you just add a little bit, then maybe it will form like a large chunk of really large droplets and help to make more rain or snow. So these are many uncertainties that people are still trying to understand, I would say. But I think the general things that people think that it on average is probably having more aerosols is going to cool down the Earth a little bit.
Hmm.
Um, but on the other hand, having more aerosols are bad for our health, right? So it's a really delicate balance that we want to reduce the aerosols. But luckily, because the aerosols can form clouds, the Earth's temperature is not heated as high as what it would have been if we only emit CO2 and all these aerosol pollutants are not emitted. As the consensus, I think people are trying to think is that it's very likely that the temperature of the Earth will be even higher.
Mm.
Yeah.
Wow. It
So
almost sounds like we have them to thank.
it's something like that. Yeah, it's like, we did pollute the air, but that kind of helped cool us down a little bit more than what it would have been, higher or risen up for. Yeah. So that's one thing. So some people are worried that as each country, especially U.S. has already gone through that phase of making the air much cleaner. I mean, there's still a way to go, but U.S. is already doing a good job. As China and India and other developing countries are trying to clean up the air, then but we're still emitting lots of CO2s, right? So in that sense, then as we reduce more and more aerosols, people will worry maybe the temperature increasing on the Earth's atmosphere is going to be even more drastic because we lose this effect of cooling down the Earth from the aerosol cloud interactions.
Wow.
Yeah.
That's crazy.
I heard it was getting really bad in India. I had some friends that visited Mumbai a few years ago, and there's so much more air pollution there now. It's burning all the trash and taking a lot of our recyclables that China used to take and doesn't want anymore. It's getting really bad in India. So
Yeah, it feels like, unfortunately, it's almost like a step you have to go through to be able to make the country more developed or industrialized.
but there must be other ways, better ways of doing all this. So
Yeah, that's the hope.
Yeah.
Hopefully, yeah, we'll be able to find a solution or good solution within like the next 10, 20 years, so other countries don't have to go through the same thing we went through.
Wow. Well, thank you, Dr. Zhang. You have been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Dr. Zhang. Please stay tuned for Something for the Weekend with Anela and from your favorite nerds. Just a reminder to continue to vaccinate and to continue to mitigate, and we will all continue to congregate.